All right, we are getting ready to go live with Alpine Air.
My dad's going to be just a minute, but he'll join us in a second.
Awesome. All right. Hello, everyone. It's Marcy Cleveland with Hudson Valley Green Homes again, and welcome to our second virtual lunch and learn, where today we're going to be talking about the magic of heat pumps with Alpine Air. We have one of our two guests here with us. This is Jamie Bogart. And Jamie, I don't know if you want to go ahead and say a few words about your role at Alpine Air, but that would be great.
Sure. Alpine Air we're located in Chester, New York. We serve mostly Orange County and a little bit beyond. I'm our operations manager. And joining us in a minute is one of our salesmen, Joe. He's walking in right now. And he does, he's the one who comes out to the house, does the evaluations, and explains all the options to you guys.
Great. Hi, Joe. I'm glad that you could join us. I don't know if you want to say a few words or we can come back to you in a minute. All right, so while Joe gets settled, guys, let's just do a couple little housekeeping items.
How's my hair, okay?
Oh, yeah, you look great. Once again, if you have any questions or comments, please leave them in the Facebook chat window and we will get to you as we go through the webinar. And also, as before, we got a little contest going on for those of you that stick around until the end of the event. The winner this time, Hudson Valley Homes, is going to donate $10 towards Plant a Tree. It's a great event that I don't know if anybody's familiar with Aroma Time Farm to Table Bistro in Ellenville. They are a green certified restaurant and they have sponsored a Plant a Tree event for Earth Day. So I hope that we have a winner and that we'll be planting 10 trees in honor of you. All right, so Joe, now that you're here and you're settled, did you want to say a little bit about your role at Alpine Air?
Yeah, I'm the sales manager at Alpine Air, and in that capacity, I'm the person that usually comes out and evaluates the home, figures out what might be the best alternative, explains to the homeowner what their options are. We evaluate the requirement from a heating and cooling standpoint for that home. We look at how tight it is. We look at essentially all aspects of the existing conditions. And from there, we make recommendations. And of course, it turns into a pricing situation and help the person through the rebate programs that are available. And basically, we shepherd the process from beginning to end.
Great. So let's talk about heat pumps, the magic of heat pumps. There's a lot of hype out there about them and what they can do and how efficient they are. So let's demystify that a little bit for our viewers. I'm going to start the slideshow and let's get started with just talking about what are heat pumps and the different types that are available. So let me go ahead and share my screen. We'll get started. There we go. Everybody can see this slide here. Types of heat pumps.
Okay,
so
we have four pictures here. The most common, and let's talk nomenclature. Heat pump, air source heat pumps are basically talked about from the standpoint of an indoor unit and an outdoor unit. The indoor units, there are four basic types. The far left picture is showing the most common one. That is the wall unit. And you can see she's holding a remote control, which gives you full control over all the unit's functions. The next picture to the right is the outdoor unit. This is the condenser and is basically the driving force behind the technology. This is where the electrical is fed. And so the next picture is very typical of a standard air conditioning unit. The technology before mini splits and the more modern air source heat pumps were units that basically looked like this and had heat pump capability, but they were largely on and off control. So they were either running or they weren't running. The modern ones actually modulate up and down, so it looks at the requirement of the particular space, and it gives you exactly what you need. That has boosted the efficiency of heat pumps and made them possible to do what we ask them to do today. So there's been a huge leap forward between those two center pictures. The far right picture is a typical geothermal unit. You can see there's some ductwork attached to it. This directly is it's a one-on-one replacement with a forced hot air system. And if we're doing a retrofit, that's what this was. It's a connection to the existing ductwork. So it's a relatively simple project to do mechanically. The rest of the system is outside in the ground and doesn't even show up. So the evaporator and the condenser, the pumps for the water system, the fan to circulate the air, all of it's inside that gray box, which makes it cool. There isn't a lot of hardware other than that taking up space.
Okay, why don't we just briefly go over each of these? I know you touched on them. Here's just some bullet points on our first one. If you want to talk about that, Joe.
The sound of a conventional AC unit outside, if you were to try to have a conversation standing next to it, it would be difficult. The new technology, you could stand next to an outdoor unit and you could talk as we're talking now. They're basically a quiet hum. The indoor units are even quieter. So from the standpoint of the question that people often ask, you know, how much space is it going to take? How is it going to be a distraction for vibration or noise? We can usually alleviate anybody's concern about those things. Heat pumps do a great job for both heating and cooling. Cooling requires less BTUs, less capacity than heating. So when we look at a house, we actually size it for the system for a heat load. So we figure out with the current windows and the insulation, roof construction, everything, all aspects of the tightness of the house, we figure out what we're going to need from a heating standpoint, and that's how we size the units. One advantage of having an indoor unit and an outdoor unit in specific spaces in the house, like a wall unit, a floor unit, ceiling cassette, is that there's no loss through ductwork. We can look at a picture down the road here, but you can lose a lot of heat in existing ductwork, even in modern codes for ductwork. I mean, you can insulate them and seal them up as good as you can possibly do, but there's always some percentage of the air that's lost, and with that air, your money. So.
Okay. All right, let's take a look then at our next one, which is the most common used heat pump.
Yeah, so
there are, it should be mentioned too that when we use the term air source heat pump, we're referring to the more commonly used names are mini splits or ductless systems. So in the past, the only option that you had was one of these units. And I don't know if you guys are looking at, I know that you could see the presentation, but if you have your the video open, you can see that we actually have one sitting above our head in our conference room. So the way that they have always been traditionally is an outdoor unit and some form of indoor unit that was visible, a ceiling cassette, one of these wall mount units. a floor mount unit, something like that. They do make ducted models now. So we can actually put ductwork in so that you just have the grills on the ceiling, and you don't have the units hanging on the wall. So aesthetically, we can kind of work in different spaces. So the most commonly used heat pumps are the air source heat pumps, which again, the ductless or mini split systems. And the way that they work is all heat pumps move heat from one place to another. So in a conventional system, you're burning a fossil fuel to, produce heat to heat your home. With a heat pump, we're taking the air, the warmth or the heat that's in the air outside or in the ground, and we're just transferring it into the house. And in the summer, we do the opposite. We're taking the heat out of the house and dumping it back outside. So that's how we're able to do it so efficiently, is we're not generating all of the heating and cooling. We're just generating the little bit that we need that we can't get from outside.
Great.
There's also cold climate models. So a lot of people know heat pumps as not really for this specific climate region, but as technology has evolved, there are units that actually work at their full capacity down to -15 degrees outside. And it's worth mentioning that when it gets really cold outside, the unit won't just stop working. Its efficiency will drop, because obviously there's less warmth in the air less heat in the air that it can collect. So they don't just, cut off and stop working. They just might become less efficient in those extreme cold temperatures. But in this climate, they can be used as your primary or your only heating source.
Gotcha. Why don't we just say a few words about geothermal?
Well, geothermal, as opposed to the slide we just saw previous with air source, the earth is stable. And if you think about air conditioning from an air source standpoint, if it's hot outside, you may have 80 degrees and you're trying to reduce it down to 72 or so degrees inside. So you're pushing up a hill. In the case of heating, you could be at 30, 40, and unless you get really bitter outside, and you're trying to make it 70 degrees inside. Again, we're pushing up a hill. Geo, if we're in heating mode, we're trying to make it 70 degrees inside. The ground is now 50 degrees, 55 degrees. And when we're in cooling mode, same thing. Instead of having 80 degrees outside in an air source, we have 50 degrees. So the ground is a tremendously better heat sink than the air outside. The technology is such that it can work very efficiently with an air source, but the technology in Geo steps it up that much more.
So I have a question for you. So Joe, do you have to have a huge parcel of land to have a geothermal system?
There are two types of Geo systems when we're talking about the outside of the system. When you look at a house and say, we know that Geo is in that house, you walk around the house, there's nothing visible. Mm-hmm. The two types of ways of pulling the heat in out of the ground is a horizontal system, which looks like pipes that are configured like a slinky, and they go into trenches 7 feet deep. The trench is about 4 foot wide, 7 foot deep, and in total from the house out to the end about 100 feet. And you would need a number of these in order to build up enough surface area for the system. If the other type is vertical, which is probably most people have heard about, that's wells. So a conventional well is drilled, a U-shaped tube is pushed down the well, and then a grout, a heat conducting grout, seals it off. So now the pipe and the rock around are in intimate contact, and that gives you the really good transfer to the earth. So you're looking at a lot more real estate. If you're going to do a horizontal system, you have to dig up a sizable area. Normally in a new house, that's a great alternative because you have an excavator there. You're going to put in a foundation anyway. It can be very reasonable to dig the trenches and put the tubing in. In an existing house, not so much. You need to have a lot of side land. And we have done some systems even recently where we did that. But they had actually a second lot essentially that wasn't buildable. With drilling, we can do that in a very small area. We've even done it, just drilled a small hole through a driveway and then patched it. So that from a retrofit standpoint is a really great alternative.
Great. And I see on this slide that there are some offsets to the installation cost with both local and federal incentives.
Yeah, so there's a great federal tax credit right now. For 2020, it's 26%. And then I believe next year it's going to be 22%, I think. So now is a great time to look at it. But the federal tax credit is a big chunk of the cost that you get back as a tax return or as a tax credit. And then there's also local utility incentives. So depending on whether it's air source or ground source, meaning mini split or geothermal, there are sometimes manufacturer rebates. And then also the utilities are offering thousands and thousands of dollars towards these systems because it's really the goal of New York State to lower energy usage, and they're putting money, to offset the cost for people to be able to afford it.
That's fantastic. Great. So let's move on to a little bit about how heat pumps work, right? Now, I know there's a lot of people out there that probably want to know more technical details, but there's a lot of us that just want to know basics. Joe, can you just kind of walk us through this slide?
Okay, we have two sides to the picture. We have winter and summer. So we see the outdoor unit on the left and the indoor unit on the right. That indoor unit right now is shown as kind of a furnace situation. This can be a wall unit, it can be anything. This is a refrigeration driven system. All geosystems and air source systems, they're basically refrigeration type units. So they're either using a condenser to provide heat in an indoor situation, or they're using an evaporator to absorb heat. And the units have a reversing capability. So the same compressor running in the same direction can send the refrigerant where it needs to, either toward the inside or toward the outside, to provide heating and cooling.
Great. And then this is sort of the inner workings of the system. A little more technical diagram there.
Yeah. I mean, we don't want to get in the weeds with this, but the conventional AC that we all know is where the arrow on the left is pointing, and it only points in that direction. The compressor and the see at the bottom there's an expansion valve. The two coils, they exist on the AC side, but the flow is always in one direction. A heat pump has the ability of reversing direction. The same compressor now is pushing gas to the right, and the condenser is being used in a heating mode. Because as you compress the gas, it gets hot, and we can take that heat and we can push it into the space that we're trying to heat. So I think that's about the depth we want to go at this point.
Exactly. Let's talk about efficiency. Let's talk about reducing carbon footprint by converting to a heat pump system. These are all things that we hear circulating around, saving money. It's good for the environment. Let's just talk about why that is.
Well, we have two types of conventional fuels, right? We have fossil fuels, and then we have electrical. the absolute worst situation you can have in your house is electrical strip heaters or some kind of electrical baseboard or something like that, which is crazy expensive. The next most expensive, depending on not only the economy but production situations, we have LP gas or we have oil, often neck and neck. Gas can burn more efficiently, but it's a little more expensive than oil. But then again, when you have oil, you got this smelly beast in your basement. It has to be cleaned regularly. It has to be tuned up. Otherwise, it runs very, very poor efficiencies. So that's probably the least attractive from a maintenance and you got usually 275-gallon tanks. They're the state doesn't want to see them buried anymore. You can't sell your house unless you pull the tank up. If it's in the basement, it's taking up space and has an odor to it. So it's not an attractive alternative. And it provides, and it gives off the most pollution. The two right-hand bar charts, bars are second from the right air source, and the far right one is ground source. And you can see that these are the least expensive alternatives because basically they have a multiplier effect. They are run on electric, but because of the refrigeration cycle and the tremendous efficiency of the new systems, they're very efficient.
Right. And I think, we mentioned when we talked before that just people maybe won't think about it right away, but after they get their first electric bill, after having a heat pump installed, they're going to notice that it goes up, of course, because it's run on electric, but they have to remember that they're no longer paying for the other utility costs of other heating systems.
Exactly.
All right, here's our next slide. And this is just a comparison of oil heat versus clean heat.
Yeah, so when you have oil, and really any of the fossil fuels, whether it be propane, oil, or natural gas, they are fossil fuels, and we're burning them to produce the heat. So it's doing a couple of things. It's releasing carbon into the air. So if we're trying to reduce our carbon footprint or just be eco-friendly, oil, as Joe said, is of course the worst and also the most costly. But they're releasing pollutants into the air. They're also, less efficient. They can have, they're subject to things like if you do have an old oil tank in the ground, it can leak and contaminate the ground, or it can be costly to remove it and bring it up above the ground. Another thing to keep in mind is that as the economic climate changes and as negotiations with other countries and all that changes, we can't really predict the price of these fuels. We do know that they will most likely increase over, a period of time. Over the years, it will go up, but there's really no way of estimating what these fuel costs will be from year to year. They also fluctuate greatly from season to season. So if you're on fixed income, for example, and you just want to know what your average monthly cost is going to be every month, and not have spikes and valleys throughout the month, fuel oil can give you that sort of problem. So when we talk about clean heating and heat pumps, again, they use electric, but they use a much more minimal amount of electric compared to the amount of fuel oil you would need for the same amount of heating capacity. And if you are able to mix it, I think we're going to talk about this quickly later, but if you are able to get on a community solar field or put solar or wind power in your own home, then that's that much cleaner. You end up with free heating and cooling at that point, and it's obviously the most clean way of producing that bit of electricity you need.
One thing I'd like to add is a safety factor. If you're burning gas, you have the possibility of releasing carbon monoxide into the home.
Right.
And I think everybody has heard horror stories about, what can happen there. Oil, not so much, because if oil exhaust is released into the home, just the smell and the soot would act like an alarm. But when you're burning LP or natural gas, that possibility is very real.
Okay. So I want to get rid of the misconception that some people have about heat pumps and their effectiveness in a cold climate. While that may have been true of heat pumps back in the 70s, I know the newer technology has really changed things. So why don't we set the record straight right now?
Yeah, we have models that go all the way down to negative 15 degrees. We have it kind of depends on your home, the area that you live in. If you live up on a ridge, if you don't, is it going to be supplemental? Is it for a specific area of the home? We take all that into account and we pick the specific model that works for your situation. But we have regular units, we have cold climate units that are rated to -5, and we have units rated to -15. And as I mentioned before, at -15 degrees outside, they don't just stop working. They just don't work at that efficiency rating that they show online, for example, because there's just not as much heat in the air for them to collect, and they just don't work as efficiently. But they're not just going to shut off at that temperature. So, we don't really experience negative degrees in this area of the country, but rest assured, if we do, the units can absolutely handle that at their rated efficiency. And they're designed to do that.
Great.
Let me just say, the biggest single thing that has changed the technology to be where we are is the fact that these units modulate, whereas almost every other kind of heat is either off or on. So the thermostat says I need heat, it turns on. When the thermostat says I've had enough, it shuts off. That on and off is very wasteful. The modern heat pumps have a variable speed compressor, and they have the valve that controls the flow of the refrigerant. In some cases, 500 little steps. So it's like having such a gentle foot on the accelerator pedal as opposed to mashing it down when you want to go and putting on the brake when you want to stop.
So let's talk about something that really can make a difference in the effectiveness of having a heat pump, and really any system, and that has to do with how tight is your thermal building envelope in your house.
Well, here's an example of all the places you can lose heat, where primarily we're talking about air leakage. Starting at the top, we have what we call the cap. In our terminology, it's the roof. The roof is the single highest heat loss component of the house. The conventional house has an unheated attic. It basically has no insulation. And so the attic is either extremely hot, like 140 degrees in the summer, and it's essentially the temperature of the outside in the winter. The ceiling has to be very, very well insulated, but even then there's all kinds of cracks and stuff that heat will go up, because your house is a chimney, and the hot air wants to rise, and it accumulates on the second floor ceiling, and it just disappears from there. The other thing we see in the attic is that conventional heating and cooling system with the ductwork. You can lose 25 or even 30% if it's old ductwork with poor insulation and all. You can lose that percentage of your heat through there. As we all know, you have wall insulation, you have windows. All these things can be upgraded to a point. On an existing house, it's very hard to increase the wall insulation. There's things you can do with talking to a energy consultant, little small things in gasketing and insulating between the foundation and the wall, and tighten the house very, very much. And when you're looking at saving money, it's really a hand-in-hand thing. You should look at both aspects of your energy dollar, losing it to the environment and how you create that heating and cooling to start with.
And it's worth mentioning also that if you have a fairly tight newer home, or you've done some upgrades, then great, give us a call. If you have an older home, or you're not quite sure about the construction of your home, definitely do one of the energy audits to really find out the areas of the home that need some improvement. And then we always recommend that you do that first. If that is a step that your home needs or that you're going to take, even just for informational purposes. A lot of these companies offer free or fairly inexpensive energy audits, but do that first, because if you are going to do some of the recommendations that they suggest, then that makes the heating and cooling system we have to supply a bit smaller. So if your house is really leaky and it loses a lot of air, then when we do our design, we're going to look at a heat loss calculation, and we're going to look at how much heating, for example, your house is expected to lose. And we design the system, the capacity of the system based on that. So if your house is tighter, that's probably a smaller system we need to design, and therefore save you a little bit of money and even help offset the cost of those upgrades that you did to your home. So we do suggest you do that step first if that's something that your home needs.
The other thing is, I mean, we're kind of talking about a whole house aspect. If you're going to do heat pump or geo system in an entire house, then the entire house is really looked at as an envelope. If you're looking at particular rooms, let's say you can improve the tightness of the windows in those rooms or anything like that, and you just want supplemental heat, or you want to heat that room, it's always been cold, or it's sweltering hot in the summertime, it makes sense to go ahead and do what you need to do before the audit. But when you're looking at the whole envelope, that's very important.
So I do encourage everyone, this next Tuesday, our third Lunch and Learn is going to be about weatherization. We're going to be talking to Better Energy. So please come back for that webinar as well if you want to learn more about energy audits and doing some upgrades to your building envelope. That'll be very informative. All right, so let's talk about how a heat pump works with solar. We just had our first Lunch and Learn about going solar. Compatible systems, I'm assuming they would be.
Yes, so as we mentioned before, the heat pump is going to collect as much, let's just choose the winter time as an example, but the heat pump is going to collect as much heat from either the air or the ground outside and transfer that heat into the house. But there is the potential that it cannot produce the amount of heat that's needed. So then it basically functions like an electric furnace at that point and uses electric to generate more heat. So if you can do solar, whether it be a community solar array or putting panels on your own home, then, like I said, it becomes free heating and cooling at that point. Also, according to NYSERDA, which is the New York State Energy Research and Development Authority, according to NYSERDA, 70% of your home's energy usage is for your heating and cooling system. So that's well over half. So if you think about ways that you can make your home closer to net zero or reduce your carbon footprint or your emissions and all of that, you can put in Energy Star appliances, or you could put in LED light bulbs, and you might see, a couple dollars reduced off your utility bill. But if 70% of your home's energy usage is heating and cooling, then that's the biggest, most effective way to make an impact on reducing your energy usage. So, and like I said, it couples beautifully with clean power production like solar, because it uses electric for any amount it needs to make up.
Great. So let's talk about installation of systems in existing homes. As I imagine, most of your customers are customers that have existing homes and they're looking to retrofit their current HVAC system. Is there a particular type of home that's better suited for the conversion versus others? What if I already have a forced air system? Is that help me at all?
Well, you really have to start with, if you're looking at geo, you have to take a look at the big picture of the amount of land you have, and the wells, and that's, you're either circulating water and converting it to forced hot air, or you're using the refrigerant up in an air handler in the attic to supply through the ductwork in the attic, sometimes both to do the whole house. So you have to look at, do I have existing ductwork? How would I run the lines? Where would the holes be drilled? Or do I have enough room to do a horizontal field?
Mhm.
So from a heat pump standpoint, you have a few more things to consider. Air source, however, you have wall units, you have ceiling units, you have floor units, you can do ducted units. So for each area in the house, there sometimes are multiple solutions. Sometimes it's aesthetics. You know, you don't want the wall unit, but a ceiling unit's less obtrusive. Ducted unit, all you see is the type of grills in the ceiling as you do in, you know, central air. So the other thing is we can often get to every area of the house. The outdoor units can have up to 5 zones connected to them. So one outdoor unit can do 4 or 5 spaces in the house.
Mhm.
And I mean, even quite a large house with a lot of individual spaces, if you put one unit on one side of the house and one on the other, we can readily run all the refrigerant lines to these individual units. And now every space has either a remote or some kind of thermostat that is controlling that space individually from everything else. Geo units tend to do large zones. So say the second floor gets a zone and the first floor gets a zone, and all the rooms are kind of linked together. Nice thing about air source is you can pinpoint, like let's say you're not using a bedroom, you can turn that bedroom down to 50 degrees. The adjacent room is your master, you can have that at 65, 70 degrees, and so on, all through the house.
Okay, great. I have, just using my house as an example, I have oil baseboard heat. And so would I keep my oil baseboard heat as a backup source? What would I do in that situation?
From the standpoint of geo, you have kind of not a perfect situation, because geo operates with a relatively low water temperature, say 100, 110 degrees. It can do the job with that temperature. Baseboard is sized for a boiler, which is running water temperature at 180 degrees.
Okay.
There are small geo units, like up to 2 tons, that can run those high temperatures, but usually at a house, you know, to any size, that's not feasible. So normally what we do is we'll do a unit. And the other thing is, you can't heat a house from ceiling registers. You need to, on the first floor, say, you need to have floor feeds. So if you have baseboard, you may have to either abandon the baseboard or leave it there as a backup and put ductwork in the basement and have floor feeds. If you already have AC or heat with ducts there, then it becomes a very easy situation. The second floor, you can heat it from the ceiling. So you can put something in the attic. Ductwork's a lot easier to put in that way. And so the second floor is usually much less of a problem than the first floor. So again, answer your question, it depends.
Yeah, I was going to say, it sounds like there's no cookie cutter solution, that it's really house specific.
Some houses that have baseboard have an abundance of baseboard. And so even though it's a lower temperature, it's still enough to heat the house with a geothermal system. Some have less baseboard, you know, linear footage, and we have to augment it with air, or if you have radiant heat, it's a perfect opportunity for a geothermal system. What we find mostly is that customers come to us looking for a more energy efficient option, or they might not even know about heat pumps, and they're coming to us to replace their old heating system or their air conditioner that just broke. And we're the ones that say, hey, based on the rebates and incentives that are available, this is actually fairly similar in price, or sometimes almost the same price, and it's going to lower your utility usage. So we just kind of naturally go that way. And most customers come to us just looking for an energy efficient heating and cooling system. And so we usually end up talking to them about both. Or they come to us for geothermal, and for some reason that's not the best fit for their home, or to retrofit it might just be a little bit too costly. And so then we, talk about the air source option. So the really best thing that you can do is have someone who's very knowledgeable in both types of systems, so you can really compare apples to apples, come in and evaluate your home in particular. And then we'll tell you exactly what your options are, what the costs are, and give you some recommendations.
That's really the key, is the level of knowledge that the contractor can apply to your situation, because it's often not straightforward. The comparisons of what your options are sometimes really, it takes years of experience to really have seen enough jobs and how they perform at the end to know what works and doesn't work.
Okay, now I'm gonna stop sharing the PowerPoint and just do some more questions with you guys. We have a little less than 20 minutes, so there's a lot of things for us to get through. Everybody's gonna wanna ask this question. It's the $1 million question. How much does one of these things cost?
Well, without doing my $1 million, so that is that's probably the most popular question that we get. And I'm just going to preface with, it's really, really difficult for us to give a price or a range that could potentially, people will stick in their mind, and it doesn't apply to everyone. But what I will give you is at least some rough guidelines. So if you're using, let's start with air source, which is the mini split systems. So if you're putting one air source system with one indoor unit. So for example, in our home, we had a screened in porch, and we ended up putting windows in and spray foaming it and wanting to heat and cool it to use it more during more seasons of the year. So we're just worried about that one room. So we have one outdoor unit with one indoor unit. I would give that a rough estimate of $4,000 to $5,000. If you're looking at a whole home system, and let's pick your average like 2,400 square foot house, and it's not like overly complicated for any particular reason, but if we're looking at a whole home system for a moderately priced house, let's give it an estimate of maybe 10 to 15,000. So then let's look at, and again, there might be rebates and incentives that
all these numbers are pre-rebate.
Yeah, they're all pre-rebate. So there could also be money available from the utility companies. And in that scenario, let's take the $15,000. Let's take the high end of that range. And let's say there's a couple $1,000 available. There's $1,000 available from the manufacturer. And then let's say there's $3,000 available from from NYSERDA. So now you're looking at, anywhere from like $10,000 to $12,000 that system could cost. If you're replacing your air conditioning system, maybe it's $7,000. So for a little bit more, you're getting a heating and cooling system. And so the amount that you'll save in utilities in the heating season will actually pay for the additional, that it costs for air conditioning only. And that we see a lot is, I'm just looking for air conditioning. But, oh, by the way, even though your heating system isn't that old, if we replace that also, now you're saving money all year long, and your heating system can just be like a backup or something. So going back to rough pricing for a geothermal system, it's a lot more difficult to give an estimate, even, for square footage, because like we said, there's wells, there's trenches, there's all different types of ways to, there's radiant, there's forced hot air, but
like water circulation systems require holding tanks and more pump,
yeah,
and more valves. And
so to give like just a rough range for, again, a moderately sized house, I would give it 30,000 to 70,000. We've done systems that are 80, 90, 100,000, but if we're going to give like a range, and because I'm giving you a $40,000 range for a moderately priced sized house, you can understand where, the price range really varies. And again, that's all before rebates and incentives. So it's very possible that you could, the utilities alone are giving, you know, in some cases, it's like $9,000 towards the system. And then you have your federal tax credit. So depending on the circumstance, and you can also use that on new construction, by the way, those tax credits and rebates. So depending on the circumstance, sometimes it's really only a little bit more to do geothermal as opposed to air source, but again, your savings is also going to be more. So your return on investment is quicker.
If,
And I think people have
if
to
you're
remember
building a house,
savings. Yeah, I just wanted to say people have to remember that the savings that you're going to have by having that type of heating and cooling system could be really significant each month.
Mm-hmm.
when new construction for geo, when we price them out compared to a conventional system, because the excavator's already there, if you have the land, we put in a horizontal, it can be within a couple of $1,000s of the conventional system. And then you have a 25-year, 30-year life system that'll save you a very lot of money. Yeah. Even systems retrofits, when you look at the financing, when consider everything in total, you can save enough money from the fossil fuels, eliminating the fossil fuels, that you'll actually have money in your pocket every month compared to running the geo, because your financing costs will be less than your actual energy costs on a monthly basis.
So let's talk about financing options. How do I pay for this thing?
Yeah, it can be a big investment for a home. I mean, nothing we do in our home is cheap anymore, right? So as Joe mentioned, there are financing options available. In some cases, there's zero interest finances. In some cases, there's short and long-term financing options with low interest rates. There's a lot of banks that are actually specializing or only offering funding for clean energy products. So for example, we work with a bank that's Clean Energy Credit Union. They only fund, and so does Enerbank actually, they only fund projects like solar and heating and cooling systems and weatherization type products. So they're very competitive with each other, and they specialize in those types of funding those types of projects. But the goal is really to, again, as Joe mentioned, the goal is to reduce your utility costs and put that money towards, your financing payment each month. But then once you pay that off in 10 years or 5 years, then that's all just money in your pocket. And for a geothermal system, if the life expectancy is 20 to 30 years, you're going to end up making money for 10 to 15 years before it needs to be replaced, and you'll be replacing it a lot less frequently. Also, on that vein, the infrastructure in the ground of a geothermal system is expected to last, like 100 years. So when you do need to replace a system, you're just replacing that indoor unit in the basement usually. So the replacement cost is not the same, 30 to 70,000 I quoted. The majority of that cost is in the ground infrastructure.
All right. Great. So we have a little bit over 10 minutes left, and there's a couple of areas that I definitely want to get to before we wrap this up. The first one is that right now we're all very concerned about being healthy, right? We're all stuck at home. We're concerned about the health of our homes, our indoor air quality. Does a heat pump system help with that at all?
If you take a look at these individual units, either the wall unit or the floor unit, the ducted units, there are individual filters for each unit. And those filters can be taken out by the homeowner, or they can be washed and they can be put back in. They're pretty efficient, and it's definitely going to improve the air quality. A wall unit will change its fan speed up or down, but it's almost always circulating air in the room when it's on. So that air is getting turned over across the filter. Baseboard, there is no filter. You get dust bunnies all over the place. Mm-hmm. Forced hot air, it moves air around in a way that can have similar effects. A good system will have a decent filter, so not such a big difference. But yes, there is air quality considerations in the units. And again, we have that carbon monoxide issue. If you have a furnace in your home, there's always even small amounts of carbon monoxide that are coming out of them.
Okay, excellent. Now, the next thing that I want to talk about, very popular right now, hearing a lot about them, and that would be the heat pump hot water heaters. So I've had some questions come in about these, primarily because of their size. They're very tall. So what do you do if you don't have, say, a basement to put these in and you have a crawl space? Is there a shorter option available?
Well, they can be put into, if, let's say you have a condo, I mean, almost always they're on a slab and you have a closet someplace where they fit. Ceiling height's normally 8 feet. It's not an issue. I mean, if you have a crawl space and no place to put it, yes, that's an issue. The heat comes from somewhere to heat the water. The heat comes from the air around it. So you need about 600 square feet of open area if you have no way of bringing in outside air. However, they come with venting kits if you want to go the route of bringing outside air in to supply the source of heat for the air pump. For the heat pump. So that alleviates the problem of putting it in a closet and making it, stone cold in there and not having it work efficiently. The new units are hybrid units. So the heat pump is able to put a certain amount of heat into the water. And for 2 people, maybe 3, it's enough to keep up with demand. If you have some guests over or you're doing, you're drawing more in your hot water, the water heater, the air source heat pump water heater will kick in electric heating as if it was an electric water heater. So you've got the heat pump working at its capacity, plus you have that kicker of the electrical element. And in that case, it's almost always sized to take care of the full load, even if it's fairly heavy.
Yeah, I think if we back up for a minute, I think we're assuming too that people really understand what a heat pump water heater is. So if we back up for a minute, when we were talking about the air source heat pumps that heat your home, there's an outdoor unit outside that is capturing the outdoor heat. And then there's refrigerant lines that run to an indoor unit. And then the heat is released through the indoor unit. So you have that outdoor and that indoor unit. A heat pump water heater is a little different in the sense that it's basically a water heater with the heat pump on top. And that's what that top box, that top part of the unit is. So it does make it a little bit taller. So if you have a crawl space, we'd have to find a different place to put it. But that's why Joe mentioned you need a decent amount of square footage around it, because it's going to circulate the air. Like, for example, if it's in the basement, it's going to circulate the basement air and collect the heat from it, as opposed to having an outdoor unit. So again, we can put in a venting system to bring outdoor air in if there's a space confinement. But that's like just a quick difference between, how the ones that heat your home and the ones that heat your water is. The water ones are sort of one combined unit. They are becoming very popular. It's not always, the right fit in each home, or we have to be a little creative, like I said, with where we put it or how we vent it. But again, we can assess your specific home and talk about the different options. And the other thing I want to mention, since we're talking about hot water, is a geothermal system is creating hot water. And so we can actually use it as the hot water to your domestic hot water for your house. So about 70% of the water that you need in your home for showers and things, the geothermal system actually already produces as sort of a byproduct, if you will. So you get almost free hot water, or in some cases, depending on how much hot water you use, free hot water by having a geothermal system.
Cool. I just want to go back to the heat pump hot water system there, because we did have a specific question about it, in that if you do have to bring it into the living area, is it going to give off cold air? And I think you talked about venting that, but you would vent that cold air to where?
Well, the number of BTUs that you're putting into the water comes from the environment around water heater. So yes, it's going to chill it. If it's in a basement and you have 500 or 600 square feet at basement temperature, it could be 50 degrees, 55 degrees, it's going to be happy and you're not going to notice that chilling effect. If it's in a closet, it doesn't work well unless it's vented to the outside. If it's on an outside wall and you can connect it to a vent that brings in outside air. So, I mean, it's not for every situation, but current state of the art burning gas to heat hot water, which is called a force vent water heater, it's the same price as one of these. And you don't have to run gas lines. I mean, you just hook electric to it and off you go. The old school water heaters, I mean, this is significantly more expensive, but you're not burning fossil fuel, and in the long run, it's going to save you money.
And there are rebates.
That's right.
There are rebates for these. So
There are incentives for them, yes.
I know Central Hudson is offering a significant rebate that almost brings the cost of these down to a conventional system. So it's kind of a no-brainer.
Right.
All right, very quickly, because we don't have much time left, I just wanted to talk about Alpine Air's involvement in the Heat Smart Orange program. If you could just maybe talk about what that program is, how you got involved in it. It's going to have to be super fast.
Yep, I could do it.
You would be great.
Sure. So NYSERDA, as I mentioned before, who they are, NYSERDA offers funding for energy efficient utilities, basically, or energy efficient equipment. So, but they're not great at spreading the word. So they partner with nonprofits to help them put like marketing campaigns together, similar to, you know, what Marcy is doing now, to put together campaigns to just communicate what rebates are available, what incentives are available, what the heating, the energy efficient technologies are, and just to help homeowners understand that. So what they did was they came together and their marketing campaign is called Heat Smart. And their goal is to have 2 Heat Smart campaigns in each county in New York State. So there was Heat Smart Warwick last year, and now this year they're doing Heat Smart Orange County. So basically, again, they have different events available. And what they did was they went through a very detailed vetting system. So they reached out to a bunch of contractors and they pre-selected, there's 3 air source heat pump contractors and 2 geothermal heat pump contractors. And we were actually selected for both air source and ground source. So we went through a very extensive vetting process so they could select companies that they knew did good work and that knew how to properly design systems. So they'll basically help you get in touch with the contractors, and we're one of them. They'll help you understand, you know, what the proposal the contractor gave you. They have energy consultants that you can talk to. They'll put you in touch with those weatherization companies, you know, to help with that perspective. But their goal is to just spread the word and help you understand what incentives are available and what technologies you should consider for your home.
Excellent. Thank you so much, you guys. We're going to wrap up the webinar now. I appreciate the information. I hope everybody got a lot out of this. Before we finish, the contest is very similar to what we did on Tuesday, and that it is, if anyone can tell me where this photo was taken in the Hudson Valley. I gave you guys an easy one today. If you can tell me where that was taken, Hudson Valley Green Homes will donate $10 to plant 10 trees in your name. You can get in touch with us on the chat box or send me a personal message. All right, guys, have a great day, and thank you so much.
Thank you for having us.
Thank you.
Bye-bye.